Hello and welcome to another Solana tutorial. Today we're gonna talk about program accounts, like the actual accounts that make up a Solana program, an on-chain program, because they are just an essential thing when it comes to Solana development that it's almost a shame that I don't fully understand them. So today I wanna get to the point of fully understanding them. And by that I mean knowing what is stored in those accounts, just in case I ever want to deserialize them. And let's be honest, you can go your whole Solana journey without knowing this. You can just use programs, or you can deploy programs yourself without understanding what's actually happening there. That's fine, because most of that functionality is abstracted away and only the validators really need to know that. And we as a dev can just say, yeah, it's a program, it's deployed, done. But I do want to understand it, and that's why I'm gonna have a look into this today. And while we're there, we might also have a look at how the actual program deployment works, with a buffer account, and how the SO file then actually gets on chain. But we will start with what's the actual data layout of the program and executable accounts, because that is still confusing to me. Here's why. Let's take, for example, the token program, token keg. One of the most famous programs on Solana. This program is owned by the BPF loader 2. So that's the loader program that owns this program account. That's the program account. But then, wait, hold on. Interesting. Here the entire program seems to sit in this account though. So this one program account seems to have all the data. Maybe that's the old loader. The new token program, yeah, there we go. That is owned by, we don't even see this here because the Explorer abstracts stuff away, which makes this whole thing so confusing. But yeah, that's more what I'm used to seeing. This one just has a little bit of sol for rent of the little bit of data of the actual program account, and the actual data is within an executable data account. This one, which then, holds all of the data for the program. 4.8 sol, that's not nothing. 690 kilobytes. So first of all, who's the owner of this program account? The regular BPF loader. Let's just check in the CLI. Solana account. The BPF upgradable loader. Yeah, okay. So there were 3 loaders. The oldest loader, then the BPF loader 2, and then the upgradable loader. That's the one that everybody uses now because it gives you upgradable programs, and they do that by having an executable data account. I think that's how this works. So was token keg never upgradable? I don't know. See, there's still so many things that I don't know. But we don't really need to analyze the old loaders. Pretty much all of the programs are now deployed with the upgradable loader. So that's the only thing that I'm gonna have a look at today, in order not to confuse you or myself. So basically, for any program, we have the program account, this one, which doesn't hold much data. It's just this, which is 32 bytes, which might be an address for the executable account, but I don't know, maybe it's something else. That might be a flag of the state of the program. It has set the executable flag to true, and only program accounts get that set to true. But the actual executable is in this one. And the Explorer even lets us download this, and I guess it will just give us the actual executable, so the SO file. But it says it's a bin file if I save it. And we want to understand what we are downloading if we're downloading this, and how we can do that ourselves. Where in that account is stored what? Because we have information like, is it upgradable? Is that stored in this executable account? Probably. Who's the upgrade authority? That's also stored in this executable account. And what's the last deployed slot? That is also stored in the executable account. Even though if we have a look at the actual program account, here it gives us all that information, and that's what makes it so confusing sometimes. If we look at the program, it says it's upgradable, it gives us the last deployed slot and the upgrade authority, but this thing is not actually stored in the program account, which makes this whole thing so confusing. Because intuitively you would think, yeah, the upgrade authority, of course that's stored in the program account. No, it's not. It's in the executable account. And what I also want to understand is that a PDA? Is that address derived somehow? Or can that be any address? And that's why we need to write it here. That I don't know. We're gonna have a look at that. So a good first start is understanding what's in the actual program account. And then later, we're gonna have a look at I should not have done that. Can I just have the first few lines? How do I do that? So in the executable account, which is not executable, but also owned by the upgradable loader, that has the entire bytes and rent for it. 9 sol, that's crazy. Hold on. Here you say 4.8 sol, but I'm also on DevNet. On mainnet it has 9 sol. Hold on. That's already a good comparison though. Also on mainnet, we have the same executable account for the same program. So this seems to be derived somehow, I guess. But yeah, interestingly, the mainnet version has more data. One would expect that the token program is the same on mainnet and on DevNet, but apparently not. Anyway, let's analyze what you find in those accounts. Starting with a program account. And that is indeed the same for mainnet and on DevNet. And my educated guess would be that's the state of the program and that's the executable data account address. But I might be wrong. So let's have a look at that. Should we decode it or should we look at source code? I think I want to look at source code. Where would I find that? An upgradable loader RS. That's in the SDK. So I'm guessing the first 4 bytes is for the enum of upgradable loader state, where 0 will be uninitialized, 1 is a buffer account. Okay, so here we go. So that means 2 is the program account. That's what we see here. It is a program account, and the program account will have the program data address pub key, which means that that will be the program data address pub key. Then 3 would be a program data account, where it has the slot and the upgrade authority address. Right, and through the upgrade authority address, since that's an option, if that's not set, then it's not upgradable. And if that's set, then yes, upgradable is true. So we don't need a separate flag for upgradable, even though that's what the explorers tell us. But you know, it's just derived from an option. Okay, and the raw program data follows the serialized structure in the accounts data. Okay, that makes sense. Probably also here, yep, the raw data follows the serialized structure in the accounts data. Cool, I mean, that already answers the questions that I had. What is stored in the program accounts and in the program data accounts? These and those things, plus the extra program data. Ah, nice. And then we also have a get program data address, because as I expected, this is being derived with a find program address for the BPF loader program. I guess that's the ID. Yep, BPF loader is our ID, the upgradable loader. So we're deriving this for this program ID with the one seed of the program address. So one given program address will always give us a fixed executable data account. And still, we write that account, even though we could always check that, but still we write that into the 32 bytes here, which makes sense because, I mean, that's just 32 bytes and memory in that case is cheaper than compute, especially if you're computing a find program address. You want to just have it stored. Plus, it's also better for security, I guess. Even though, no, if you would compute it, that's deterministic, it would be the same. But for efficiency reasons, it makes sense to store it than to have to compute every time. So yeah, that's the type of account, which tells us it's a program account. And then comes the data account address. So if we decode that, we should get this address. Should we do that as an exercise? Just to get used to the new Web3.js as well. Doing things with the new Web3.js as an exercise. Yeah, that sounds about right. Let's get us the Solana Web3.js in version 2. I mean, essentially, I think I only need the RPC anyway. Because the RPC should give me a get account info for an address, the token program, and then program account, and what else do you need? A commitment. Not that I really care about that. This account doesn't change much, so it doesn't really matter. And then, hold on, here we send this. Response has some value for us, which has the actual data. There we go. And if it's executable, which should be true. Is it executable? Just to see if we can get it that far. It is executable, and the data length is 48, which is what we would expect for... Actually, no, that's not what we expect. We would expect 36 size of a serialized program account. Show me again. Here we have 36. Data. Oh, that's base 58 encoded. Ugh. We need to get the actual data. Does the Web3.js have a base 58 decoder? Then I can say decoder decode provided byte array at the given offset. Oh, that's the confusing thing again. Wait, so I need the encoder? Encoder.encode. Yeah, again, oh, this is so... They explained it to me why they do it like this, but I still disagree. Because for me, the base 58 string is the encoded thing. So I want to decode the string to the bytes. But they explained to me that no, it's the other way around, because they always go from what they have. They explained it to me and I was like, I disagree. You know, but it is as it is. Confusing. For me, personally. But well, okay, let's encode the string into bytes. Yeah, because the bytes is not what you work with. No, I do want to work with the bytes, which for me seems to be the decoded thing, if we're talking about base 58. The raw thing is the bytes. I ain't gonna complain. I'm just gonna take it as it is. Okay, we encode it to bytes. Sure. Then we have the extra data, bytes. What type is this now? Yes, a uint 8 array. Wonderful. And from that, if we get that data length, then we should also get 36. Yeah, that's better. Okay, good. So we have the data, and now we can do checks like, is it a program account? And we can check that by checking the first byte to be 2. Then I can say, this is a program account. Check. This is a program account. Wonderful. And I just need to check the first bytes. I mean, there are 4 bytes reserved for the enum, but we literally just have those 4 choices anyway. 1, 2, 3, 4. So comparing the first byte is enough, in my opinion. But yeah, there are 4 bytes reserved for the state. And yeah, then we know we have a program account, and now we can just read the address. So wait, what's the type for this in the new Web3.js? It's address. I want an address from bytes. In the old Web3.js, I did it with new pub key and put in the bytes there. But how do I do it here? Maybe I want an address encoder or decoder. Is it the decoder that I want? What do you take? You take bytes and you give me the string. That is what I want. Would I call it decode or would I call it encode? I think here it's the right way around for me. I would have called the decoder because what I have is the raw data and I decode it into the address, which is a base 58 thing. That's why decode. Here for me, that's fine. So data for until 36, except we're not in Rust, so that's not how this works. Subarray, begin at 4, end at 36. For 32 bytes of data. And then we just log the executable account and we would expect that, yes, that's the thing that we expect. That's also what we got here. Plus, I can also say what we expect with find program. Where is that again? I knew it all in the old Web3.js, but I don't anymore. Where's the find program address? Get program derived address? That's what you call it? Okay, fine. It's so confusing. It used to always be find program address, but now it's get program derived address. Sure, whatever. You just gotta get used to the new Web3.js, which sometimes is frustrating. And that's okay. We can do frustrating things. So the program address is my program account and the seeds, oh, that's async. Hold on, wait, no. That's the BPF upgradable loader. Do I have the BPF? I'm sure in some package of the Solana Web3.js, we have this address, but I'm too lazy to find it, so I'll just copy it in there. So that's the actual owner of the program account. And then in the seed, I put the program account. That gives me address and bump. So I get the first, which is just the address, the expected address. Call it expected address. And we would expect that those are the same. Which, hold on, I don't even get. The seed heading is 0 with length exceeds maximum of 32 to bytes. So once again, I give you an encoded address and you want the, oh yeah, that makes sense. Okay, sure. So here the address, it will take it as the string. Okay, fine. Then we need to get address encoder and encode this 2 bytes, which no, again, seems like the wrong way around again. No, I encoded from an address to bytes, and here I encoded from bytes to data. See, this is just confusing, but well, the types tell you anyway what they take. It takes the address and it gives you the bytes. So yeah, apparently it's the encode. Fine. So we encode the address, give it the actual address, the address type, and encode it to bytes. Sure, whatever. Let's see if that works. There we go, it works, and it gives us the same executable account. So the expected one is the same one as the actual one. Wow, amazing. So we also know how this actual executable account is derived now. Wonderful. We can derive it and we can read it from the actual on-chain account. So that was for a program account. That was, you know, this thing. We read this and we read this. Pretty simple. And while we're here, we might as well also look at the executable account. They call it program data. So let's also unpack a program data account as a writing exercise manually. I mean, there is the SDK that would let us do this probably in Rust here at least. But I want to do it manually because it's always good to do it first low level and then use the SDKs. Because that way you can now do this for any type of account, not just for this specific program account. That's the general way of doing things. Right, we have our program data account, which we just got from here. And then we get the account info from there. And then check if it's the 3, then it's a program data account. Forget about the rest for now. Let's just check if this actually says it's a program data account. No. Encoded binary base 58 should be less than 128 bytes. Probably because the data account is so big, it doesn't want all that data in base 58. Okay, how can I tell you to use base 64 encoding? Do I have more context slot at the send? Do I have any in here? Just the abort signal? That's also not what I want. How can I tell you to give me that thing in base 64? I hate those types. It's so confusing. Okay, somehow I need to get to this filter. And here I can also not provide a filter, right? Oh, but here I can say encoding. Hold on, where do I do this? So if I do it without, I guess it uses base 58 per default, but there is a base 64. Oh, you gotta see, that's why we did this tutorial on TypeScript to understand this. So it takes config with the address, config, and a read-only encoding. So that means I can just write into the config of this, because it's an AND, encoding. It doesn't suggest that, but I will do it anyway. Base 64. No overlap matches this call. Damn it. But I see it here. I want to use this one. Oh, I just mistyped it. What did I say? Encoding. Ah, classic. I just need to say encoding. There we go. Perfect. And if I say encoding base 64, then this thing will give me, oh, I love types, this is so fun. Then the response will also give me the data in base 64, which means I don't need no base 58 encoder. I will need a base 64 encoder. And again, I say this is the decoding, but you know, whatever. I'm not gonna argue with the people who developed the Web3.js. Just gonna write code that works. And to me, seems confusing. Sorry, so why the data has base 64 encoded data response? You have a 0 and a 1. What is this? This. Show me this. What is this? The response for get account info API response with this. This, which has this. What is this? Ah, yeah, okay. So it gives me the bytes and it says this is in base 64. Ah, sure, whatever. So basically that just means that there is the 1 that says base 64 and the 0 that should then be the actual base 64 string. Okay, good. So we decode, encode. I still say decode with the encoder. We decode the data with the encoder to get bytes. And then we should have the bytes, and then we should not get this error anymore. Let's see. There we go. And we get the entire 69 10,000 bytes. And this is indeed a program data account. Wonderful. And it's not executable because it's not a program account. So if I were to manually want to decode this, what info do I have in there? Well, the slot and the option for the upgrade authority. Let's start with the slot. That's just, how would I encode a number? What other decoders do I have? Bytes decoder, option decoder, struct decoder, Lambert's decoder, block hash decoder. Wow, there are so many decoders. I basically need a generic number decoder, a constant decoder, bytes decoder maybe. What does this is interesting. What does the decode from bytes, which is a read-only uint8 array, it gives me a read-only uint8 array. Yeah, sure. No. Oh! Look! There are more decoders for all of the different types as well. Oh, this is cool. Maybe a bit confusing that you need to get a separate decoder for all of those things, but it's cool that we have them. So what is the slot? It's a U64, no? So U64 decoder we want. Maybe the encoder? I don't know. I think it's the decoder. We give it the read-only array and we get a big int. Oh, perfect. Yeah, that's exactly what I need. I give it the data subarray from 4 to 4 plus 8, which is 12. And that should give me the slot, which is a big int. Let's see. Deployed slot 3236. Is that correct? It feels a bit wrong. But no! 3236, yeah. It's the last deployed slot. We are on DevNet anyway. That's why we got those. On mainnet, we're at 289. The current slot is 312 on mainnet. On DevNet, currently at 352. So DevNet has been living longer. Or processing faster. You can't tell, but also it's been living longer. Cool. So we can just decode that with the U64 decoder. And here, yes, here I definitely would say it's a decoder. Because from the bytes, what we want is the slot, what we want is the U64, so we decode the bytes into the U64. Therefore, we use the decoder. Here it makes perfect sense. Whereas for the base 58 encoder, oh yeah, to make that consistent, yeah, that makes sense then. So that's how they explain it, right? If you want the base 58, you use the decoder to get the base 58. From that perspective, it makes sense. If you want the base 58, the decoder gets you the base 58. But what messes with my mind is that base 58 is an encoding. And therefore, this whole thing makes it a bit confusing. So really what this is a get base 58 encoding encoder. And the other thing is the get base 58 encoding decoder. Yeah, okay, not confusing at all. But if we would call it get base 58 encoding decoder, people would complain. So yeah, to be consistent with this, if we want the thing, we use the decoder to get the thing, then yeah, it makes sense. But it's just confusing because that's an encoding. Anyway, just to help you understand and help myself understand why this is so weird. It does have a consistency to it. It's just a confusing consistency. Okay, but anyway, here it's not confusing at all. Here I want the U64, so I get myself the U64 decoder, and from the bytes, I get the U64. Bam. Okay, cool. Can we do the same for, wait, what else is there? The update authority, which I already saw get an option decoder. Creates a decoder for an optional value using option T. So T is then, do we need to provide the type for the option encoder? Aha, so it needs an inner type. Okay, so hold on. Before we decode here, we need to give this another decoder. So we decode an option of a public key, so we get an address decoder. And that thing will decode me an option for an address, which is the authority. Yeah, option for an address. Nice. And then we actually decode it. So where is it in the data? From 12 to 12 plus 36, because 32 is the address and 4 is the option. There's 4 bytes. Yes, 4 bytes to specify whether the option is set or not. I think that's how it's serialized. Let's see. If authority, how would I say, is sum? Would you really use that option thing for sum? I don't think I should use that option thing, no? I can be like if that's none. I've never worked with options in TypeScript. So internally it uses it with that, but I do want to use that type. Where do I get that type from? Small none? Oh, okay, so I have, again, functions. Yes, functional programming, of course. I have none, is sum, and is none. Okay, so what I want to use is none or is sum authority. Then program is, and upgradable is true. There you go. As you would expect, because the authority is set. And if it is set, then how do I get the option out now? For a sum type of t, there is a value. So authority should have a value now. Yes. And the funny thing is, authority here only has the option and not the value. Only after I checked it for is sum, it has the value. Types in TypeScript are so fun. So here I can access the value now because it guarantees me the value because I checked it for is sum true. Funny TypeScript. Right, so the actual authority, that's the authority option, but that's the actual authority address. Let's call it upgrade authority. And then we get the upgrade authority 3URR. Yes, that's also what we saw. Hold on. Nope. On mainnet, we have a different authority. Yeah. On DevNet, it's the 3URR. Cool. So we can also decode a program data account. And I leave it as an exercise for you to decode a buffer account if you want to decode that. It basically also just has the authority address as an option and not the slot. And then comes the raw data. Oh yeah, we still need to decode the raw data. So that's the actual program file then. How am I gonna do this? Am I just gonna save it? I mean, first let's get the data. So let's get the executable subarray 12 plus 36. Basically, I just want to save this. Write file sync. Let's just say that's the SO file. Can I put the bytes here directly? I guess so. Let's see. Let's just run this and see. Yeah, we get an executable which has 674 kilobytes, which is roughly what I would expect. Hold on, this is mainnet again. Let's download that. And I have it here. And look at that. This and this both have the same size. Ha! And they probably... let's open anyway in a text editor. Boof. Yeah, so we have an ELF file. Ooh, here we just have F. In my executable, oh, apparently my offset is wrong. I just have an F. But the rest seems to be the same, right? And then we have a bunch of nulls and stuff. The very end, text, no. Yeah, it looks like an executable. Except I have an offset issue. Why do I have an offset issue? My program data account size of program metadata and program metadata should be 45. What I put is 12 plus 36, which is 48. That's 3 bytes different. Aha. So probably the option doesn't have 4 bytes but 1, which makes sense because I want to be somewhat efficient. Option decoder. Just for more entertainment, let me quickly log this. Yeah, we see it just has 1 byte set to 1 saying the option is present, which means I'm off by 3. Yeah, okay. So I don't need 36. I need 32 plus 1, which is 33 for this one. And then I also just have 45 for this one. And then we should be correct again. Then it should have the actual exact same size and not just on kilobytes. And now it should also give me the ELF at the very beginning. Nice. And that should be the actual executable. So if you ever want to download a program to decompile it, there you go. That's how you do it. I mean, also you can just go to the Explorer and hit that, where is it here? And hit that download button. But you know, this is the more fun way, or at least for me, because I understand what's happening here. I do it manually and I get the bytes and I write the file. Yeah. Right. And just to prove that that's actually the case, let's quickly deploy a program just to check. Cargo init, lib, cargo add Pinocchio. Oh, it's spelled with an H. Pinocchio. Pinocchio. Like the people from Tirol. Pinocchio. Okay. Super simple program. I'm just gonna cargo build SBF this. Nice. And then I get a... Where's my deploy? Oh, hold on. I'm keep forgetting that I need to do this. Do it again. There we go. Now I get a deploy. And here is SO file. Look at it in a text editor. This is definitely smaller. It just has 1.21 kilobytes. But it looks similar to what we saw before, except few lines. It also starts with del and ELF. And maybe somewhere in there we would find the string super simple program. Yeah, because it needs to store that somehow, this string, this static string. So yeah, cool. And if we deploy this, so we can say Solana program deploy the target deploy simple program SO. Boom. And we can do this in 4 transactions total. Cool. And the program ID is the 7xp. Can look at it here. 7xp. The executable data is BAHXX. I deployed it in this slot. The depk deployment king is the upgrade authority. A bit over 1.2 kilobytes of data. So if we run our scripts now, not for the token program, but for this one, let's do the program account first. There we go. This is also executable. It also has 36. It is a program account, and the executable is indeed the BAHXX. Nice. If we then plug in this thing here and run this, then we see the data length 1285. It is a program data account. We just deployed it in this slot. It is upgradable, and I am the upgrade authority. Nice. And it also saved the executable SO, which has, if we list it, 1240 bytes, which should be the exact same as in the program target deploy. This one also has 1240 bytes. So this thing and this thing, they are the exact same. We can get the deployed program off chain again with this simple script by just getting the account info. But make sure that you get it in base64, otherwise the RPC doesn't give you so much data. Yeah, cool. We learned a bunch here. I like it. We learned what's actually in the program accounts and what's in the program data account. Most of it is in the program data account, and in the program account there's just the link to the program data account. But that's cool. We practiced using the new Web3.js. Getting some experience in that is definitely always good. And yeah, we can now decode the program account and get the actual executable of the program data account, which is cool because we will need that when we actually want to decompile programs. But that is a topic for another video. And I will also leave the topic of how the actual deployment works for another video. I mean, we just saw it. There were 4 transactions being sent. This guy has a total of 5 transactions. There was 1 airdrop plus 4 transactions for deploying. But I will leave analyzing that for a future video. Let's stay with one topic per video. And yes, it is related, but on a bigger scale, everything is related, right? It's all Solana content. And yeah, I don't want to make this video too long. I have been recording for 2 hours, so it should make it a nice, sweet 45-minute video. And I'm happy with that. I don't want to give you too much in one go because the chunks I give you are quite big already. You know me. This is just the kind of video I like to make. Deep dives into really understanding what's going on here, and we now really understand what's going on here, and I like that. Yeah. So Here are other places where you can figure out what's going on there in some other videos. And then you can give this video a like and subscribe if you have not done that yet. And yeah, maybe let me know what else you want me to make a deep dive on. Because like this seemed so basic that I really wanted to look at it in depth. And I did. And I like it. So yeah, hope you learned something. And I will see you in the next deep dive. Until then, bye bye.